Hello, this is a recording video that will focus on outlier detection within your data set. So again, this is a practical application or illustration of finding outliers. Now, there are three different types of analysis that could be done in order to identify an outlier. One is we could look at a specific individual variable, and we could identify or seek to identify observations that are outside of the norm for that specific variable. Then another way we could do this is we could look at the relationship two variables have with each other and identify observations where that relationship between two variables is unusual or strange or odd. The third way we could do this is to look at several variables all at once by observation, and again, look for a pattern where the observation looks unusual based on what we would expect from all the rest of the data. That would be the multivariate illustration. So we're going to look at some of these, and again, an illustrative application of how you can go about doing this. Now, keep in mind that a lot of times we're very careful about wanting to not delete data or discard observations. If we collect the data properly, and if the survey is a good survey or the data protocol is followed correctly, then we have no real reason to think that the data is bad or that the observation is bad. So we have to have a lot of proof or evidence that it is before we decide to discard it. This illustration will use the HBAT data set. So you can access that and you can run through some of this on your own. So there's no reason why you can't do that if you so desire. So I have pulled up here the HBAT data set that we have from our analysis. Now this is the HBAT 100, so there's 100 samples observations here, and we have a whole bunch of variables. We're only going to focus on a few variables here. Number 19, X19 here is actually satisfaction, so that's a good outcome variable for us to be focused on. And then some of these other variables we think may contribute to satisfaction. So we want to see if we can find some of these 100 observations that may be out of place or they may seem unusual, to determine whether they should be deleted or not. So the first thing we'll do is look at a univariate approach or identification for potential outliers. And with univariate, what we want to do is look at particular observations that seem well outside the range of typical. And so what you can do is set a rule like the 2.5 standard deviation rule, where if an observation falls 2.5 degrees, if you will, away from the norm, or deviations away from the norm, then those individual candidates or observations may be candidates for outlier status. So what we'll do here is we'll take this variable by variable. We'll do a couple variables to illustrate the process. So we can take like x6, for instance, or any of these for that matter. X7, we'll start with X7. The textbook and the data set analysis actually does this for X6 all the way through X19, so that can be something to refer to. But we'll just look at X7. We're going to go to Analyze. We're going to go to Descriptive and then Explore. Okay, so I already have X7 in here actually, so that's a little handy. But if we didn't, we could put X6 or X7 or X8 or any of these, of course, could fall in there. So that's not a problem. We can put that in there, and again, we're exploring. We're looking at, we can check outliers here, although we're going to mechanically do this, so you don't really have to do this, but you can do this if you want. We have descriptives. It's actually handy to do outliers because the SPSS will automatically look for observations that fall away from away from the mean, but we want to be a little bit more specific so we know what we're doing. So check outliers, check descriptives, and that's really all we're going to worry about here at this point. You can look at stem and leaf plots or histograms maybe too. We'll look at histograms. Stem and leaf plots may help, but sometimes just a visual chart might help too. So we'll do that. We'll click OK, and we'll have our output window appear. We have 100% of our respondents here. There are no missing data on this particular variable. Importantly, what we want to do is we want to remember the mean here. So we have 3.672 as our mean. And then we have our standard deviation, which is 0.7005. Okay, 0.7005 is what we're focused on there. Now, if we want to be within 2.5 deviations, then we can multiply 0.7005 by 2.5. If we do that, we'll do 2.5 times 0.7005, and we roughly get 1.75. So just remember 1.75 above the mean. Anything greater than that is going to be it's going to be something we could label an outlier, or 1.75 below the mean. So if we added 1.75 to our mean, then we're going to have 5.42. So just remember 5.42 in the back of your mind. We'll put 5.42. That'll be the upper bound. So we have 5.42. This is going to be the upper bound for that, and then our lower bound for this would be it would be our mean minus the 1.75. So it's going to be 1.992. So anything above any score or reported score above 5.42 may be an outlier. Anything below 1.92 would be an outlier potentially as well. So again, it's 2.5 times the standard deviation. And in this case, we had 2.5 times 0.700, what was it, like 1 or something like that, 5.5, right? So then that was going to equal our 1.75, and then we just, our mean in this case was 3.672. So 1.75 plus and our 3.62, or minus our 3.62, plus or minus. So it would be plus or minus. The mean is going to give us our bounds that we want to have. Okay. So just keep that in the back of your mind. Actually, I can probably, well, it's not going to work quite 100% right here because things are going to get moved around. Oh, well, actually, it's right here. So that we look at our extreme values that we have. And again, I told you that SPSS gives you these, but it doesn't necessarily use the 2.5 rule. It probably uses a two standard deviation rule. So we have these different cases, and anything above 5.42. So here's case number 23, 26, and then number 5. The number 5, those are all above what we have here. And then anything below, no. So we need something below a 1.92, and none of those are below. So this extreme box here is a little bit maybe too extreme. What we might consider a cutoff, again, 2.5 standard deviations would say that 23, 26, and 5 might be candidates in terms of ones that are cases here that might not be appropriate for us to keep. Um, okay, so as we go forward, we can continue to do this with every single variable. Now, let me point out something specific here. Uh, the cases correspond to the numbers here, the actual observations, not necessarily the ID number. So the cases that I identified as potentially out of place may not correspond directly with the textbook, but if you input the textbook data, the HBAT data directly, and you don't move things around, some of these observations have been moved around in my data set that I'm using, so don't let that throw you off if you're corresponding with the textbook and you're looking at this data set here. The process is the exact same for this as you move forward. Okay, so so that's good to know, and that's something to keep up with. Yeah, so so now what we want to do, and it's a bit laborious, but what you want to do is you want to do this for every variable. So you want to identify the outliers for every variable, and then what you want to do is see if any of the observations repeat themselves across all of the variables. So in other words, we had this oh, I guess I here I'll just do this again. We had descriptive, we had explore. I'll just run this again so that we've got it back up here. We had these extreme values 23, 26, and 5. The next question is, if we did the same analysis, only we did it for another variable, so we'll do this maybe for not x7, but maybe we'll do it for x6 now, and we would need to run this over. So we have 7.81, and we have a standard deviation of 1.39. So we have 1.39 times 2.5, so 3.48, excuse me, plus or minus 3.48 away from the mean would be our extremes. So we have 7.81 plus our 3.48. So anything above 11.29 is problematic. And then we have 48, and then we want to take that 3.48 away from 7.81, and then anything below 4.33 on this variable would be problematic. So anything above 11.29, we have our cases here. There's nothing. There's no cases that are above 11.29. And then anything below 4.33, we don't have anything below 4.33. So for x6, there are no cases that would suggest that we would want to have extreme values. So those observations that were in x7 do not repeat in x6. So how extreme are those observations in x7? Well, we need to go through x8 and x9 and all the other variables, and we need to see if any of our observations repeat themselves. Okay, if that's the case, then those might be candidates for deletion. All right, so that's univariate, a case of univariate analysis when we look at one variable at a time, and then we look for outliers that repeat across multiple variables. Another thing that we can do is we can look at two variables at the same time, and for this we can look at a chart like a scatter plot type of a plot, and in this case I've chosen satisfaction, number 19, satisfaction, as an outcome variable, and then I have again our x7 here, And if I do this scatter plot, then what I want to do is I want to look for data points that are way outside of where a trend might occur. So this one here, these two here, and I can, might be able to go in and find out what those observations are. I could do that and try to identify that on a bivariate basis. If I could identify those two variables or those three variables, chances are they're the three that I found earlier that were outside of the norm or outside of the average typical thing. So what you actually do or can do is create a confidence interval, and anything outside of a confidence interval between two variables may be candidates for exclusion. More powerful though is to actually go in and look at a multivariate approach, which is a little bit more powerful. So what we're going to do for the multivariate approach is we're going to go actually into something, we're going to do a regression, even though we don't really care right now about the regression results. What we want to find is combinations, we want to find observations who have unusual combinations of responses. So like each observation here, like each respondent gave us an answer for x6 all the way through x19. And we would expect there to be some similarity in how these responses relate to 19. What we want to look for are abnormal responses in combination with all the variables together in relation to 19. So what we'll do is we're going to go into analyze and then regression, linear, and we're going to put in 19 for our dependent variable, because we have to have a dependent variable, and then we're gonna put in these other variables here. We're actually gonna put in 6 through 18. Now again, we don't care so much to know the actual like coefficients and betas and stuff like that. We're not really interested in model fit. We're not doing this for a regression. What we're doing this for is for the Mahalanobis distance score. Okay, so this is the Mahalanobis d squared that we're really kind of focused on. All right, so this is going to be a score, a composite score of how each response is to the norm. Okay, in a regression context. So this is going to return a score, and what we want to do is take this and divide it by the number or the degrees of freedom that we have within the context of the regression. All right, so the degrees of freedom here will be the number of independent variables. So if you count the number of independent variables, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, then that should be, I think, 13. So we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to have 13 degrees of freedom. And so what we're going to do is take the Mahalanobis score divided by 13. Okay, and what we want to look for is anything greater than, again, 2.5. All right, so I'm going to hit continue, and I'm going to hit OK. And what this will create is a new variable in our data set. So we have all of our regression stuff, but again, that's not what we're interested in here. What we're interested in here is this new variable right here. So this is the distance. This is how far apart the distance is between the variables that we have and what we're interested in measuring. So if we look at 13 and we have 2.5 as our cutoff margin, then 2.5 times 13 will be our cutoff point. So 32.5 is actually what we're concerned with. Anything above 32.5 would be an outlier here. Okay, so what I'm going to do, I'm going to resort this data set by that variable, data, and then I'm going to sort cases by our new Mahalanobis distance score, and descending, I guess, is fine. So it'll go from the largest to the smallest. And so now we have the data set here that's reordered by score. So again, what I said was anything above 32.5 is going to be a potential outlier. So anything above 32.5. So we have a 40 and a 36. And again, this is actually back in line with the text. If you look at the textbook and we look at the ID numbers here, 98 and 36 fall in line with what the text suggests may be out of bounds. Because again, if we took 40, if we took the 40.008 and change and divided it by our 13, it's going to be 3.08. That's above 2.5, so that's bad. And then we take and we know 36.86 divided by 13, 2.84. That's above our 2.5 cutoff, so we know that one's bad. We take our 32, just for illustration, 32.41, divide it by our 13, and we have 2.49, which falls just below our cutoff. So this is the multivariate approach to identify potential outliers. Now, here's the thing. You want to do univariate analysis, potentially bivariate analysis, and you can do this multivariate analysis, and it's pretty easy. The thing is, though, we need to have consistency. We need to have 98 and 36 here repeatedly being an outlier in order to discard them. If you go through this analysis, you're not going to find any variable that actually does this with this particular data set. So again, finding outliers is one thing. Discarding them, you have to have a fairly high standard for your benchmark. You really have to have a lot of variables that the respondent is an outlier on in order for it to count. Now, if you only have 5 or 6 variables in your total analysis and somebody is an outlier on 4 of them, yeah, that's probably a problem. If you have 40 variables and a person's an outlier on 4 or 5 of them, no, that's not a problem at all. Okay, so this has been an illustration then of outlier analysis and what to do about them.